My dear students and parents, by God's grace, my educational videos are available to 10th Cbse, plus 1 Cbse, plus 2 Cbse, NEET and IIT students in the subjects Maths, Physics, Chemistry, Zoology and Botany in English language. We have already calculated the molarity, volume percentage and mass percentage in the previous videos. Today we are going to calculate the molarity of the solution containing 5 gram of sodium hydroxide in 450 ml solution. What is asked? It is asked to find the molarity of a solution. In order to find the molarity of a solution, we require 3 data. One is the mass of the solute. The second is the molar mass of the solute. The third is volume of the solution. In respect of mass of the solute, in the sum, the mass of the solute, sodium hydroxide, is given as 5 gram. In the case of volume of the solution, it is also provided in the sum as 450 ml. That is volume of the solution. But the molar mass of the solute is not given in the sum. From the available information, we have to calculate the molar mass of the solute sodium hydroxide. We can find the molar mass of the solute sodium hydroxide from its molecular formula, that is NaOH. So, from this sum, we can get all required data. Now we proceed to find the molarity of the solution. In order to find the molarity of the solution, first of all, we have to write the formula for the molarity of the solution. Formula for the molarity of the solution is number of moles of solute sodium hydroxide dissolved in 1 liter volume of the solution. Molarity equal to number of moles of solute sodium hydroxide by 1 liter volume of the solution. On seeing the formula, we understand that if we know the number of moles of solute sodium hydroxide, we can find the molarity of the solution. In the sum, the number of moles of the solute sodium hydroxide is not supplied. So we have to find the number of moles of the solute sodium hydroxide. How can we find the number of moles of sodium hydroxide? We have to write the formula for number of moles of solute. That is, given mass of solute sodium hydroxide by molar mass of the solute sodium hydroxide. On seeing the equation, we realize that if we know the mass of the solute sodium hydroxide and the molar mass of the solute sodium hydroxide, we can find the number of moles of the solute sodium hydroxide. In the sum, the mass of the solute sodium hydroxide dissolved in the solution is given as 5 gram. So we can substitute 5 gram in the place of given mass of solute sodium hydroxide. Then what about molar mass of the solute sodium hydroxide? Whether it has been given in the sum? No. the molar mass of the solute sodium hydroxide is not provided in the sum, then how can we find the molar mass of the solute sodium hydroxide? If we add the atomic masses of all elements contained in a molecule, we can get the molar mass. Therefore, the molar mass of solute sodium hydroxide equal to, in this formula sodium hydroxide, that is in this molecular formula sodium hydroxide, there is only one sodium atom. The atomic mass of one sodium atom is 23. So it is written here. There is only one oxygen atom. The atomic mass of one oxygen atom is 16. It is also written here. Moreover, there is one hydrogen atom in the molecular formula of sodium hydroxide. So the atomic mass of one hydrogen atom is 1. If we add 23 plus 16 plus 1, we will get 40 grams per mole. This is the molar mass of the solute. What is the formula? Given mass of solute sodium hydroxide, it is given as 5 gram, as we already told, and we have found the molar mass of the solute sodium hydroxide as 40 grams per mole. If we substitute these two data, we will get 5 by 40. 5 by 40 equal to 1 by 8. 1 by 8 equal to 0.125 mole. Now we have determined the number of moles of solute sodium hydroxide dissolved in 450 ml of solution. The meaning of the formula number of moles of the solute is, if the mass of the solute is given as 40 gram, we can write the number of mole as 1. But in the sum, 40 gram of mass of solute is not given. In the sum, only 5 gram of solute is given. This 40 gram represents the molar mass. We know that in 1 molar mass there is 1 mole. To 40 gram mass of the solute, the number of mole is 1. Therefore, to the given mass of 5 gram of solute. This is the meaning of the formula to find the number of moles of the solute. Then coming to finding the molarity of the solution. To find the molarity of the solution, here also we have to write the formula for the molarity of the solution again. The molarity of the solution equal to number of moles of solute sodium hydroxide by 1 liter volume of the solution. So here number of moles of the solute is determined as 0.125. So that we can substitute the number of moles of the solute as 0.125. Of the solution is given as 450 ml of solution. So we can write the number of moles as 0.125 and the volume of the solution as 450 ml of solution. What is the meaning of this formula for the molarity of the solution? In 450 ml volume of the solution, the number of moles dissolved is 0.125. But we don't need the number of moles dissolved in 450 ml of the solution. To find the molarity of the solution, we need the number of moles of the solute dissolved in 1 liter of the solution. Therefore, I have written as to 450 ml of the solution, The number of moles is 0.125 as we have determined. Therefore, to 1000 ml of solution. Why it is written 1000 ml of solution instead of 1 liter? Because in the sum, the volume of the solution is supplied in milliliter, so that we have to convert the liter into milliliter. We know that 1 liter equal to 1000 milliliter. So it is multiplied by 1000 ml of solution. Then we have got the formula for the molarity of the solution equal to 0.125 by 450 into 1000. So if we calculate, we will get the molarity of the solution as 0.278 mole per liter. We can also write the molarity of the solution as 0.278 mole per decimeter cube. The molarity of the solution can also be written in another way. That is, the molarity of the solution equal to number of moles of solute sodium hydroxide by 1 liter volume of the solution. The number of moles of the solute sodium hydroxide is 0.125. If we convert the given 450 ml volume of the solution into liter, we will get 450 by 1000. So in the denominator we are getting the fraction 450 by 1000. So this 1000 will go to the numerator, so that we will get 0.125 by 450 into 1000. We will get the molarity of the solution as 0.278 mole per liter, as we have already determined. Dear students, if this video is really beneficial to you, you can share with your classmates and friends, and you can subscribe my channel.